What is a crystal lattice in metals? Imagine a city built with perfectly aligned blocks, each one fitting seamlessly with the next. That's similar to how atoms arrange themselves in metals. Instead of buildings, we have atoms, and instead of streets, we have a repeating pattern called a crystal lattice. This structure is a three-dimensional grid where each atom sits at a specific point, repeating endlessly in all directions. The reason atoms from this pattern is to keep the metal stable and minimize energy. Metal atoms are held together by metallic bonds, which involve a sea of free electrons surrounding positively charged metal ions. These free electrons act like glue, holding the atoms in place while allowing them to slide past each other when needed. This balance between attraction and repulsion results in the atoms settling into fixed positions, creating the crystal lattice. The smallest repeating part of this structure is called a unit cell. Think of it as a tiny building block that, when repeated in every direction, makes up the entire lattice. The distance between neighboring atoms in this pattern is called the lattice constant, usually just a few hundred picometers, which is a tiny fraction of a micrometer. There are different types of crystal lattices in metals, each with unique arrangements. One common type is the body-centered cubic structure, where atoms are at each corner of a cube with one atom in the center. Metals like iron and chromium have this structure. It has a packing density of about 68%, meaning 68% of the space is filled with atoms. Another type is the face-centered cubic structure, where atoms are at each corner and in the middle of each face of the cube. This arrangement packs atoms more tightly, giving metals like copper, aluminum, and gold different mechanical properties. Then there is the hexagonal close-back structure, where atoms are stacked in a hexagonal pattern, common in metals like zinc and cadmium. This pattern also packs atoms very efficiently. The structure of the crystal lattice influences how metals behave. It affects their strength, flexibility, and how easily they conduct heat or electricity. When metals deform or break, it often starts with tiny defects in this lattice, like vacancies or dislocations. These imperfections can grow under stress, leading to cracks or failure. Understanding the crystal lattice helps explain why some metals are more brittle while others are more ductile. It also helps in designing stronger, more reliable metal parts for everything from bridges to electronics. So, the next time you see a metal object, remember that its strength and durability come from this tiny, orderly arrangement of atoms working together in a crystal lattice.